Okay, so final exam stuff. Let's see if I can answer all the questions about all the things right now. Yes, Monday is 246, so your final exam in here is on Monday. IU students taking this exact same course get to sit for 2 hours to take the exact same final exam that you guys are taking. Because I don't make up the final, they send it to me, I print off what they send me, and I give you guys the same exam. That's one of the requirements, is that everybody takes a common final exam. Because IU students get 2 hours for it, and Pike gives us 90 minutes, that does not strike me as fair at all. So what I did last semester, what Mrs. Glaze did last semester, is especially with us being 6th period, and I will send emails to everybody that needs to know tomorrow, but I was going to email everybody's 5th period teachers and let them know that you need to come here beginning C lunch. So you need to eat either A or B lunch. If that's not your normal lunch period, you'll need to go and eat either A or B lunch on Monday. You will need to report in here C lunch, so that you have the same 2-hour window to take your exam on Monday. Does that sound reasonable, fair?
No.
I mean, if you don't want the full 2 hours, I'm cool with that, but
I'm just playing that stuff.
there are 16 questions on your final exam.
16,
which is like 5 less than last semester.
No part A and
Yeah, because they
Some of them have multiple parts. Some of them just are what they are.
My question is, can I please calculate how my grades gonna be by here?
You can absolutely calculate your grade.
Okay.
Brendan, what did you say?
I'm not interested in like.
I'm sorry, I still can't hear you.
There are naturally multiple choice, of course, right?
There is no multiple choice. None. Yep. Hold on, let's find out.
There's nothing about this.
This is called I don't remember. It is on your syllabus. It's calculated differently based on whether you're talking about your high school grade or your college grade. And both of those are on here. So I'm just in the syllabus. IU grading scale. Where's it at? There we go. For your high school grade, no. For your high school grade, 20% of your grade is coming from the final exam. High school grade, 20%. For your IU grade, the final exam is 30%. So it's weighted heavier for the college portion. Yes, ma'am.
So if we're if we're at the border of a certain grade, will you just bump it up?
I feel like you should, honestly speaking.
If we're
You have to understand, like, it's been a hard semester, you know.
Let me put it this way.
It's been a hard semester.
Let me put it this way.
Trauma and everything.
I'm going to only talk about one particular number, but read into it what you will. I have never, ever, 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 ever had a student fail my class with a 59%.
Oh, I'm not giving
What
it.
if you got 58? Because that's what I got.
Wait, that was so funny. Why did you say Pedro? What?
Woo. Okay. Pedro, I feel like this meme was made for you.
Pedro, like, it's because you be on that little phone. What should we do on that
Wait,
phone?
no, Pedro, homework.
Says, why are you turning in a blank sheet of paper? Because all of my answers are imaginary numbers.
Should be 81, 60.
Stop. You can't
Okay.
put him like that.
If I got a 0.
So we're going to do a quick, review of vectors, another look at vectors. One other thing that you guys need to complete. I'm going to try to leave some time at the end of class for you to get this done. It does not have to be done today, but it does need to be done before end of school on Tuesday. You need to fill out an online course questionnaire for IU. So if you're not taking the class for dual credit, this would not apply to you. I'm pretty sure everybody in this room is taking this class for dual credit. If you are taking the class for dual credit, this is what IU is requiring. You need to fill out this questionnaire. This is a pretty standard thing in college courses where you evaluate your course the course materials, you evaluate the instructor and whatnot at the end of the course. So they can make sure that you're getting what you need to out of it, and they can make any necessary changes in the future.
Did you get points for it?
You know when you guys were asking me if you're on that ledge, whether I bump things one way or the other?
Yeah.
I would complete the course eval.
Okay, girl, I got you. I'm gonna write all good things.
Okay.
Okay.
I will write them.
I'm gonna be like, the best. Like,
I'll write 3.
I'd complete that course evaluation.
she needs a raise.
2 pages.
Okay. No DBQs. No.
No, I write DBQs naturally, so it'll be a DBQ.
All right. Review of vectors. So we've got 2 vectors here that we're looking at, vector A and vector B. They didn't tell us exactly what direction they're going, but I know they're vectors because they said so. So there is a direction associated with them, along with a magnitude. What is the magnitude for vector A? 4.3. What is the magnitude for vector B? 2.1. What else do we know about these 2 vectors? Yeah. I don't necessarily know which direction vector A and vector B are going in, but what I do know is how they are oriented to each other. They're acting on the same point, but they're not coming at it from the same direction. How are they related to each other? Like if I talk about their position, there's a 30-degree angle between these 2 vectors, all right? So while we don't know what A and B are necessarily, you can think of vectors like we've got these 2 different forces acting on a single thing. So like if I throw a baseball, the force that I put behind it would be one vector. If the wind is blowing, that's also going to act on the baseball, and it's going to affect where it ends up. So that would be 2 vectors acting at the same point. Does that make sense? Both of those things are affecting where the baseball is going to go and going to land. We've got these 2 vectors that are acting on the same point, and we know that 30 degrees is the smallest positive angle between these 2. One thing to remember about vectors: their position, their location is not important. Their direction is important, their magnitude is important, but their actual location, if I were to sketch them on a graph, remember, a vector that is like up 2 and over 3 is exactly the same no matter where I place it on the graph. So the way I'm going to work through this one, we are going to place one of the vectors. Since they didn't tell me where it was located, I can choose where to place it on my graph. I'm going to place one of the vectors on the positive x-axis. It does not matter whether you choose vector A or vector B to be the one on the positive x-axis. Location does not matter. Direction matters, but location doesn't. All right, so here's my x-axis. Do you guys want to put vector A or vector B on the positive x-axis?
Okay.
Sounds good. It does not matter. You get the same final answer either way. So I'm going to put vector A on the positive x-axis. And we said the magnitude of A is what? 4.3 pounds. Vector B has a 30-degree angle between it and vector A. So I'm going to put its starting location on the origin, and I'm going to bring it out like this. Here's my vector B, and I know that this angle right here is 30 degrees. B has a magnitude of 2.1 pounds. So far, so good? I could switch those two around. I could have B on the positive x-axis, and I could have A at that 30-degree angle. Same final answer. We need to find the magnitude of the resultant vector. When they say the resultant vector, they want to know, since I've got these two vectors acting together, how do we put things together in math? Add. If I put these two vectors together, what will the result of that be? So I'm going to add vector A and vector B together, and I'm going to find the magnitude of that. Again, I'm not finding where it's going to end up. I'm going to find what kind of force is behind it. Does anybody remember how to find magnitude? Square root, yeah. It's literally almost exactly the same as the distance formula. So I'm going to take the x component of our vector. We're going to square it. I'm going to take the y component of the vector and square it. We're going to add those together, and I'm going to square root it. It is our distance formula. If I'm going to add the two vectors together to get the resultant vector, I need vector A and vector B in component form. Let's revisit component form. Do you guys remember the wedge notation? Wedge notation tells me I'm working with a vector. If I know the magnitude and I have the direction, I can write component form for any vector. We would write this as the magnitude multiplied by, think about your unit circle. Think about the ordered pairs around your unit circle. The x part of the ordered pair, is that sine or cosine? Cosine. So magnitude times the cosine of our angle. That would give me the x part of the component form. For the y part of the component form, it's almost exactly the same, but instead of cosine, we're going to have what? Sine. Pull this back on my screen here. There we go. All right, so I wrote that down because we need component form for vector A and for vector B. We decided to place vector A where? On the positive x-axis, which is how many degrees? 0 degrees. Positive x-axis, 0 degrees. You guys have told me you know the magnitude for vector A. What's the magnitude of vector A? So I'm going to do 4.3 times the cosine of 0 degrees, and then 4.3 times the sine of 0 degrees. And that gives me vector A. What's cosine of 0 degrees? 1. So I've got 4.3 times 1. So I'm going to rewrite this as just 4.3. What's sine of 0 degrees? 0. What's 0 times 4.3? 0. So here's a simplified version of my component form. Please stop me if I start to lose you. Let's try to write component form for vector B. What's the magnitude for vector B? 2.1 times the cosine of, what angle is vector B at? 30 degrees, so cosine of 30 degrees. Yes.
You know how you said you had to, like, when you throw vectors, you had to use it from that north on? Do you still have to do it? Like,
That's if we're going to write it as, if we're going to write our answer, the direction of our answer as a quadrant bearing. Then we have to do the north, south, east, west. They have no directions here. So we are not worried about quadrant bearings at all. That's a great question, though. What would the other part of my component form be for vector B? 2.1 times the sine of 30 degrees. Are we able to simplify cosine of 30?
Yeah.
What is cosine of 30 degrees?
1/2.
Square root of 3 over 2. So I could write this in simplified component form as 2.1 radical 3 over 2. What's sine of 30 degrees? That's the 1/2. So 2.1 cut in half for the other part of my component form. How we doing? Are you guys okay with how I've written these components and where I've gotten all the numbers from? Yes, ma'am.
Is it okay? Because I feel like I'm doing myself a lot. Is it okay if I leave it as 2.1 cosine 30?
Yeah, absolutely. Absolutely. All right. I need the resultant vector. So what are we going to do with these two vectors? We're going to add them. So I'm going to take this vector right here and this vector right here, and we are going to add these to get the resultant vector. So vector A plus vector B. It's still going to be written in component form because the result of two vectors is another vector. Do you guys remember how to add vectors together? Yeah, we add x plus x, comma, y plus y. So I'm going to add the x parts of these two vectors. So I'm going to have 4.3 plus 2.1 radical 3 over 2. What would the y part of the resultant vector be? 2.1 over 2. Okay, so here is my resultant vector. We don't need to. I mean, you could combine like terms and give it a common denominator and write it as a single fraction and all that jazz if you want to. But this isn't our final answer, so I don't need to go through all of that right now necessarily. We don't want to round it at this point because that will change our final answer.
So you can't make 2.1 divided by 2, 1.05?
You could make it 1.05, absolutely. Because that would not be rounding it. You still have an exact answer there because you have a terminating decimal. Yes. What did they ask me to find here? The magnitude. So I need to take this right here. We are going to square the x part. We are going to square the y part. We're going to add those two squares together. Oops. And then we'll do what to the whole thing? Square root it. This will give me the magnitude. Grab your calculators. I want you guys to do that. You will need to give an approximate answer because it will not be a terminating decimal.
Yeah, she changed this one to 3. But I love it.
Has to be in the good.
Yes.
So she can just simplify it.
Mm-hmm. I'm sorry, one more time.
Oh, yeah.
Take it out to 3 places, but yes. 6.208. Yep. All right, give me just a second and I will write that down up on the board. All right. Yes, ma'am.
We can use calculate with those kind of questions. Or
With this kind of question, absolutely. And on the final exam, when you guys go to take it, the ones where you are supposed to use a calculator clearly say, you may use a calculator for this question. So, and this would be one of the ones that would say that.
Are there gonna be times where you're gonna take away a calculator or wait till-
I will not take it away from you now. So 6.208. Does that come with units? Pounds. 6.208 pounds of force is what the resultant vector would have behind it. So one way to think about this, if you're running and the wind is blowing, if you're running into the wind, will that make you go slower or faster? If you're running with the wind, will that make you go slower or faster? Faster. These two aren't exactly in line, but these two forces are mostly acting in the same direction. And so the magnitude of that result is going to be much bigger than either one by itself. Does that make sense? Again, it's kind of like if you're running and the wind is behind you, maybe not directly behind you, but it's kind of like this. It's going to push you faster. You're going to have better times. Before we look at question 2 on here, what do you guys still want to know, or what are you still confused about here? Yes, ma'am.
So this is all there is to such a problem.
To a problem like this, yeah.
That's all there is to it.
This is all the pieces. Yep. And I've got quite a bit more written down up here than what you would actually need because I was like, remember how to do component form? Obviously, I don't need to see how to do component form on your page. I would just need to see you doing component form. Right. Let's go down and look at number 2, and then I've got 2 problems on the back that are exactly like the front side, just with different numbers for you guys to practice on your own with. So looking at number 2 here. We've got 3 pieces to this question, and each piece builds on the part before it. They tell us in part A that we have a vector. How do I know it's a vector?
Because it says so.
It does not. I mean, it does, but not with words.
That's the direction.
Yeah, that little like partial arrow over the top, that tells me it's a vector. It's also written in wedge notation. That's another way I know it's a vector. It says over here that it is a unit vector. Does anybody remember what a unit vector is? Has a magnitude of 1. Unit vector means it has a magnitude of 1. They told me the x part of this vector was 1/3. They did not tell me what the y part is. That's what I'm being asked to find. But I know what its magnitude is. So I'm going to set this up as a magnitude problem. What would go underneath the square root sign? 1/3 for the x part. And what do I do to the 1/3? We're going to square it. And then what else do I need to do? Yep. Plus y squared. And I know it's going to come out to be what? 1. So now we just need to work backwards to find y. What's the first thing I want to do? Square both sides. And we can square the 1/3 at the same time, right? What does squaring both sides do to the left-hand side?
Take out the square root.
Gets rid of my square root. Yes. And what is 1/3 squared?
That is 1/9.
1/9 plus y squared equals 1. Subtract 1/9 from both sides, so that means y squared is what?
8 over 9.
8 over 9. I don't want y squared, I want just y.
Oh, it means square root.
Square root it. Okay, so square root both sides. Normally when we take a square root of both sides, we get how many answers? 2. And I would here as well, except they gave me a little piece of information at the end. What assumption do they tell me to make? It's in the first quadrant. So the y part of the ordered pair, the y part of this vector would have to be what type of number? Positive. Y must be positive. So I don't have to worry about the negative here. All right, so I have y equals the square root of 8 over the square root of 9. Can I simplify square root of 8? What is square root of 8 simplified? 2 square root of 2. What's the square root of 9? 3. There's y. I'm done with part A.
So can you leave it in decimal form as well?
So the test is, the final exam from IU is pretty clear that they want all answers as exact unless it says to approximate a value. So exact answers would be reduced radical form. So radical 8 over 3 would not receive full points. 2 radical 2 over 3 would, because that's reduced radical form. Terminating decimals, improper fractions, those are all fine. If you're going to write fractions, it has to be fractions where the numerator and denominator are both integers. So nothing like 1.5 over 7. Has to be integer over integer. Yes, ma'am.
It's gonna be like the same, like all the tests. Like if you don't get the right answer, you're gonna give it kind of couple
Partial
points?
credit,
Yeah.
yes.
Okay.
Partial credit will be awarded where it is deemed appropriate, yes. One of the other things too, and this is on the cover sheet of your final exam, so I feel fine sharing this with you. If you don't know how to do a problem, write down everything that you do know that would be relevant information. Don't spend time writing down irrelevant information. But anything that you can write down that you know about the problem, that I could give you points for, like, okay, you might not know how to do this, but you do know something about it, write it down. All right, part B. Given vector A as above, so we just found, they told us the x part of the ordered, or not the ordered pair, but the x part of the vector was 1/3. And we just found the y part is 2 radical 2 over 3. So this is the vector that was described above. And now they're throwing vector B into the mix. They want me to find the exact value of the dot product. Do you guys remember how to find the dot product? Yep. So dot product for my vectors, A dot B. We're going to take the x parts of both vectors, we're going to multiply them together. We're going to take the y parts of both vectors and multiply those together, and then we're going to add those two products together. So what is the x part for vector A? 1/3. And I'm going to multiply that to the x part for vector B, which is 1. That is going to get added to the product of the y parts for these vectors. What's the y component for vector A? 2 radical 2 over 3. And the y component for vector B? Square root of 2. First part's pretty easy. 1/3 times 1 is just 1/3. Plus, I'm going to leave that denominator alone because my radical 2 is just going to get multiplied to my numerator. What's 2 radical 2 times radical 2? 4, because it's going to end up being 2 times 2. So I've got 1/3 plus 4/3. So A dot B is what? 5/3. Nice. And that's all I need for part B. But if you can't get the answer to part A, you're kind of stuck in the water on part B. How we doing? You ready for the last part? Yes, ma'am.
Oh, sorry. I thought that was a 3. The square root of 2, I thought that was square root of 3.
Oh, yeah, no, square root of 2. Part C. Theta is the angle between these 2 vectors. We want to use the information from parts A and part B to find the exact value of cosine theta. Cosine theta, when we're talking about 2 vectors, this is the ratio of A dot B in my numerator. Hey, look at that. That's my answer to part B. So I already have that. Divided by the magnitude of vector A times the magnitude of vector B. What's the magnitude for vector A? Look all the way back at the beginning.
Oh, so it's doing the same.
Yep, all of these parts are the same because we have the same vector A all the way through.
Oh, so
It's
it's 400.
400?
400.
No, not problem number 1. I'm still staying on problem number 2.
Okay.
Why? It's a unit vector. A, yes, is a unit vector. Yes, sir.
What are the little lines right there?
That's how we indicate magnitude. It looks like absolute value, except it's 2 lines instead of 1. So its magnitude is 1.
So cosine is equal to the vectors over magnitude, or the dot product?
Dot product of the vectors over the product of the magnitude of the vectors. Yes. And this is true for any vectors. Anytime we're looking at 2 vectors together, cosine of the angle between them is equal to their dot product divided by the product of their magnitudes. So what's the only thing I still need to find to actually calculate cosine? I need the magnitude of B. How do I find the magnitude for B?
Square root of 1 squared times 1 plus 400.
Yes. All right, so the magnitude of vector B is equal to the square root of 1 squared plus radical 2 squared. What's radical 2 squared? 2. So the magnitude of B is what? Square root of 3. I have everything I need to substitute in now. Cosine of theta is equal to, what goes in my numerator? 5 over 3. What goes in the denominator?
You say absolute value? Oh, sorry, you said magnitude.
Magnitude. The double lines mean magnitude.
Magnitude of 1, magnitude of square root.
Close. We found, so once we know the magnitude, we don't need those lines around it anymore. Yeah, so it's just going to be 1 times square root of 3. So I've got 5/3 over radical 3. Can I leave a radical in my denominator like that? No. Be nice, but no. Cosine of theta is equal to 5/3 times 1 over radical 3, because radical 3 is in my denominator. So 5 over 3 radical 3. Can I leave my final answer like that? Also no. What do I have to do? Yes, we have to rationalize our denominator by multiplying top and bottom by radical 3. So what will this be when I simplify it? Five square root of 3 over what? Over 9. Do I need to put anything in my calculator? Do I need to do inverse cosine?
No, you need cosine theta.
I need cosine theta. This is cosine theta. If I do the inverse, then I'm finding theta and not cosine theta. So this would be my final answer. All right. The problems on the back, like I said, are almost exactly like the front side. I want you guys to work through those. I will put my answers up on the board so that as you work through them, you can check your answers against mine. And if you get stuck anywhere, I am more than happy to help.
Ms. Paul, I think I'm gonna see you again next year.
That's not what I want to hear at this
No,
point.
just second semester. First semester
Okay.
I got a C, so I'm good.
So you think that's good, that's better?
Remember, if you study hard for your final exam, that will replace your lowest test grade, and it can make a big, big difference at the end.
So study
Like a
more.
whole letter grade?
It can more than make a whole letter grade difference, yes.
So if you start at the lower end of the letter grade, you can go up to the next letter?
Yes, it can. That's normally very hard to do with a final exam, but with that lowest test replacement policy that they have, it absolutely can make more than a whole letter grade difference. Think about it this way. Like if your lowest test grade was an F, and you get a B on the final exam, the difference between an F and a B is huge. And you just took that F completely out of your grade and you replaced it with a B like it was a B all the time. It makes an enormous difference.
Final exam and the other exam with the same grade?
Yes. Yeah, so if on your final exam you get a B, the B goes in for your final exam, and the B becomes what used to be your lowest test. Yes. Yes, sir.
Is the answer sheet to the practice final exam, is it on Canvas?
It is on Canvas. Yes. All right, let me pop the answers up here real quick, guys,
Oh, wow.
for number 3 and number 4. Because we are riding up on the end of the class period pretty quickly, and I want you guys to be able to practice with these and know what the answers are. Number 3, 8.091 pounds. Number 4, part A, x is 2 radical 10 over 7. Part B is 23 over 7, and part C is 23 radical 11 over 77. This is for the back side of this page right here. Final exam review packet, I do finally have all those solutions up and posted for you guys. Let me show you where those are. If you need me to pull this back up again, I'm more than happy to. But on our class Canvas page for today, it is right down here at the bottom. Spring final exam review key. That's all my work. I didn't type out all the answers separately. Long story short, and not to get a pity party, there was an unexpected pet death in my family this week. So I've been dealing with that when outside of school.
Thank you. I appreciate that.
But I'm still working to get stuff up for you guys. So, yes, sir.